Hello, hi everyone. Welcome to the Student the Brand. This is your Shiva sir. Today we are going to discuss about Grade 12 Physics, JEE and NEET current electricity topic. Current electricity topic we are discussing. So here we will discuss completely current electricity. Current electricity. Current electricity. Here we can observe the rate of flow of charge the flow of charge through unit cross-section area. The net charge flowing through cross-section area per second is called electric current. Net charge. So if you're taking the cross-section, if you're taking the conductor, so here like this is a conductor. This is area of the cross-section. Area of the cross-section. Okay, area of the cross-section we are taking. Okay, so area of the cross section of the wire, and here also I'm taking like this area of the cross section. So current equal to I equal to Q by T, the net charge flowing through unit cross section area per second, or the flow of charge through unit cross section area per second. So flow of charge per unit time also we can say I equal to Q by T. I equal to Q by T. And I equal to dq by dt. So that is nothing but instantaneous current. So you can observe like instantaneous speed, instantaneous velocity, instantaneous acceleration. So what is instantaneous? So at that particular time, so fan is rotating, train is moving, bus is moving. At that particular instant, so what is speed of the vehicle? What is the velocity of the vehicle? What is the acceleration of the vehicle? Okay. So at that particular instant, so what is speed of the vehicle? Speed of the velocity of the vehicle or acceleration of the vehicle at that particular instant. So we are finding like here also at the particular point at particular time. Okay. So at certain interval. So at that particular instant we can say at particular instant what is a charge moving in the conductor, that is called instantaneous current. Instantaneous current. So I equal to dq by dt. I equal to q by t is the total net charge, right? And S unit of current is ampere. SI unit of current is ampere. SI unit of charge. So 1 ampere is defined as 1 coulomb of charge flowing through unit cross section area per second. 1 ampere is defined. 1 ampere is defined as 1 coulomb of charge flowing through unit cross section area per second. So 1 ampere equal to 1 coulomb per 1 second. 1 ampere equal to 1 coulomb per 1 second. 1 ampere is defined as 1 coulomb of charge flowing through unit cross section area per second is called 1 ampere. SI unit of current is ampere, SI unit of charge is coulomb, SI unit of time is second. So 1 ampere is defined as 1 coulomb of charge flowing through in cross section area per second. So that is nothing but current. So here 3 points are there. So related to that, point number 1 will get the flow of charge. Flow of charge. Your first point number 1, delta Q equal to I into delta T. Point number 2, if Current is the function of time, so the flow of charge can be obtained. Integral t initial t final I into dt. And third one, so the charge flow can be obtained. The flow of charge can be obtained by area under the graph I into t. IT graph. The area under the graph of IT graph. Okay. So these are the points related to charge and current we discussed till now. Okay, now based on the magnitude and direction, current can be divided into two parts. Okay, so based on the magnitude and direction, current can be divided into two parts. Based on the magnitude and direction also. Based on the magnitude and direction, current is divided into two parts. Current is divided into two parts. One is direct current. First one is direct current. Second one is alternative current. So direct current, you can observe direct current. So magnitude and direction does not change. Magnitude and direction is not changing in this. Cell, battery, DC dynamo examples. Cell, battery, and DC dynamo example for DC. Coming to alternative current. So both magnitude and direction changes. Both magnitude and direction of current changes. So example, AC dynamo. Okay. So in DC, both magnitude and direction does not change. So in AC, both magnitude and direction of current changes. Coming to drift velocity and relaxation time. What is drift velocity and relaxation time? Drift velocity and relaxation time. So drift velocity is nothing but so normally current is flowing in the conductor. So anyway, current. So electric field will be there. Okay, if the current is flowing in the conductor, electrical field will be there. So electrons will move opposite directions. So we can take drift velocity. So one electron. So we can take many electrons. So just I am considering for showing the direction of electrons. Electrons will move opposite to the electrical field. For that, I drew this one. Okay, one electron. So it's moving opposite to the electrical field. Okay, right. Here, drift velocity. So first of all, if the electron is moving the electrical field, experience the force. True or false? Yes or no? Correct. If the electron is moving in the electrical field, it experiences the force. So that force, F equal to E into E or F equal to Q into E. Okay, done. So Q into E and F equal to, we know MA and MA equal to E into E. Then A equal to E by M. So I hope it is very clear to you. And here, drift velocity. So acceleration we understood now. Drift velocity. Normally, electron is moving in the conductor. Okay. Suppose there is a running race. There is a running race. So people start running. Okay, running race started. People start running. So, like suppose we can take 5 members or 5 persons are participated in the running race. So they started running. Okay, one person is moving with the 20 kilometer per hour. So another person 30 kilometer per hour, 40 kilometer per hour, 50 kilometer per hour, 60 kilometer per hour. Like suppose. So that much speed. So more than or less, it depends. Okay. So they are moving. And that too a small, see, like this small enclosure, small area. Like best time you imagine. So 100 people are moving in a small narrow region. Then what happens? So one person will hit another person, one person will hit another person, one person will hit another person, that person will hit another person. Like that, keep on collision will take place, keep on hittings will be there, keep on bombardment will be there. Same here also, electrons are moving in a enclosed area. Okay, in a closed area, very narrow area. So what happens? Electron will hit another electron. That electron will hit another electron. So then keep on collision will takes place, keep on bombardment takes place. Then one electron is moving with a different velocity, another electron is moving with a different velocity. Keep on collision will takes place between one electron to another electron. Okay. So that electron will hit the walls of the conductor also. Walls of the conductor also it will. So first electron is moving to some velocity, next electron is moving to some velocity. After collision, they are moving with a different velocity. The average velocity of an electron is moving in the conductor. The average velocity of an electrons moving in the conductor. That is called drift velocity. Drift velocity. And the same definition, little bit change. With a small difference, we will discuss about relaxation time. Sir, I have doubt what is relaxation time. Okay, so drift velocity we understood, sir. Like one electron is moving with a different velocity, another electron is moving with a different velocity, one more electron is moving with a different velocity. If you are taking average velocity of an electrons are moving in the conductor, that is called drift velocity. Very good. I understood. But what is the relaxation time? So, I said there is a collision between one electron to another electron because they are moving in a closed path, in a closed enclosed. So, one electron hits another electron, that electron with another electron. There must be a time gap between one collision to another collision. Yes or no? There is a time gap between. There is a time gap between one collision to another collision. Yes or no? Right? The average, see, this electron will kill another because besides of it. After going, we will go to that one. Like you know the marbles. We will play the marbles, right? Marble. Hit the one marble, that will go to the another marble and hit. And this marble will go to the another marble and hit. If you take more number of marbles in one place, there are many marbles. So there is no particular count, just you can take random count. Marbles are there, so you took one marble and you throw on it, okay, on the remaining marbles. So your marble hit that another marble, that marble hit the another marble, like that keep on collision takes place. So one collision to another collision, there is a time gap. So the average time gap between the two collisions, that two successive collisions, one collision, two collision, three collision, we can't consider between the time gap between one collision to 100 collision, one collision to 77th collision, one collision to 66th collision, one collision to 86th collision. We can't say like that. We have to take the time gap between, the average time gap between the two successive collisions. Like we know the numbers 1, 2, 3, 4, 5, 6, 7. Likewise, the average time gap between the two successive collisions is known as relaxation time. Relaxation time. There is a drift velocity and relaxation time. Now, current and drift velocity, or drift velocity and current. Drift velocity and current. Now, same, we'll take drift velocity and current. Shall we? Drift velocity and current. So every time you remember that word, so you should recall the definition. Current, rate of flow of charge. SI unit of current is ampere, SI unit of charge is coulomb, SI unit of time is second. The average velocity of an electron, the average velocity of an electron or moving conductor is called drift velocity. Drift velocity. Okay, so current, the rate of flow of charge. I hope it is very clear. Now, I am taking the conductor here. So this is the conductor. This is the conductor. Area of the cross section will be there. Charges are moving inside of the conductor. Yes or no? Charges are moving inside of the conductor. Right. I can understand. Sir, charges are moving. Yes. So current is there. If charges are moving, current will be there, right? Yes. And if the current is moving, electrical field will be there, right? Yes. If the electrical field is there, electrons are moving opposite to the electrical field. Okay, if more number of electrons you are taking, that is a drift velocity. Yes or no? So, everything is fine. Everything is under control. Good. Nice. So, the problem is length, or here you can take from here to here. I am taking the length of the conductor. Suppose only that length we can take. So, there is infinity length. So, we can't say from here to there, there to here, like that. But we are taking from here to here, L. No, velocity. Velocity equal to displacement by time taken. So, I am taking length by time. So, from here to here, delta t. Okay. Time. And here drift velocity I am taking Vd equal to L by delta t. So L equal to Vd into delta t. We know volume. What is the volume formula? Length into volume equal to length into area. This is the volume. Length into area. This is the velocity, drift velocity. So now volume, if you are taking Vd into dt into area of the cross section. Here is nothing but area of the cross section. Okay, done. So in a particular volume, how many electrons are present? In particular volume, how many electrons are present? Volume is there in the particular volume. Length and volume. So in this particular volume, how many electrons are there? So number of electrons. Number of electrons present in the particular volume, N into Vd into delta T into A. So we know the quantization of charge. Q equal to Ne, quantization of charge. This is N, so number of electrons. And delta Q I am taking now. N is nothing but N Vd delta T into A into E. Sir, one more question. We know the current. What is current? So, the flow of charge delta Q by delta T. So, substitute N Vd delta T into A E by delta T. So, here can I cancel delta into delta T? So, what is the remaining? N E A V D. Sir, here one more point is there. Current density. What is that? Current density. Current density. What is the current density? J equal to I by A. So J is nothing but N E A V D by A. Now shall we cancel A? Then current density equal to NEVD. Current density equal to NEVD. Understood? So that is the current density. Check once. So denoted with J. So drift velocity and current. I hope it is very clear. Just check. So if you have any doubts, you can ask. If you have any doubts, you can let me know. If you like the content, if you like the explanation, do like, share, and subscribe to Student the Brand. Okay, check once. You can give like, then I can continue with the little more energy. Right now, we will discuss about resistance. So if you like the content, if you like the channel, so do like, share, and subscribe to Student the Brand. Okay, so with your support, with your encouragement, so I'll take more number of classes. Okay, so if you keep supporting me, definitely I will do great work. Okay, so thank you so much for being a great supporter. Thank you for encouraging. So I'm happy. Definitely will do it. And so soon we'll start test. I'll start the test like MCQ's point of view or doing. We'll do. Okay, soon I'm going to take the. Okay, I'm going to conduct a test. So through online only. I will let you know. So the process, everything. Right? And one more thing, demo classes are available. So not only physics, remaining subjects also. Those who are interested, you can contact to this number. So then, resistance, 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 resistance. So resistance. Resistance is the phenomena of opposing the electric current. Resistance is the phenomena of opposing the electric current. Resistance is directly proportional to length of the conductor. Resistance is inversely proportional to area of the cross section. R is directly proportional to L by A. R equal to rho into L by A. R equal to rho into L by A. So R is directly proportional to length. R is inversely proportional to area of the cross section. R is directly proportional to L by A. Okay. Now, R is a resistance, and rho is a resistivity. Okay, so R equal to rho into L by A, rho equal to RA by L, So ohm meter square by meter. So then ohm meter. SI unit of resistivity is ohm meter. SI unit of resistivity is ohm meter. So very, very important. So resistance depends on length of the conductor. Coming to resistance. resistance and resistivity. So first point is resistance. Okay. So R equal to rho into L by A, rho equal to RA by L, and third one, sorry, second one, third one, and fourth one. So R equal to rho into L by A, rho equal to RA by L. So resistance depends on length and area, so it does not depend. So it depends on temperature, and here metal of the conductor, and here also temperature and metal of the conductor. So it does not depend on length and area. So it does not depend on length and area. Okay. So length and area it does not. So resistance and resistivity. Resistance and resistivity. One second once. Current electricity. So R is directly proportional to L, R is inversely proportional to area, R is directly proportional L by R equal to rho into L by R, rho equal to RA by L. Ohm meter square by meter, meter get cancelled, rho equal to ohm meter, resistance and resistivity. So I hope it is very clear. Okay. Still resistors are connected in series, resistors are connected in parallel. So I'll be able to discuss, and few more points are related to current electricity problems also we have to do it. We'll do that. Okay. So if you like the content, so due to time bounded, so I'll continue the class tomorrow. Tomorrow we'll continue the class. So thank you so much for joining and attending and listening my class. This is our sir from Student Brand. See you.